melts, so its surface area decreases at a rate of, so this is problem 14. If a snowball melts, so that its surface area decreases at a rate of 1 centimeters squared per minute. We have to stop and discuss this. What does it represent? So it decreases, so it means it's negative. What does it represent? The snowball melts and its surface area decreases at -1 centimeter, or it changes at -1 centimeters per squared per minute. So what does this represent? Obviously, it's a rate of change, so it has to be a derivative. So let's denote the surface area by S.
ds over dt.
Of course. Awesome. So now we can go back and continue reading. Find the rate at which the diameter decreases. Now this is the trap, because this has to be taken into account only at the very last step. Find the rate at which the diameter decreases when the diameter is 10. I don't want to use d for diameter because d is used for derivative. So I'm going to say the diameter is denoted by w. So find the rate at which the diameter decreases when the diameter is 10. When w equals 10 centimeters. So what are we asked to determine when the diameter is 10? And is decreasing, so I make myself a note, make sure that I get a negative number so I don't mess up something. So how fast is the diameter decreasing when the diameter is 10? Which we know we do not take into account. So what is this? Should I show the problem again? What do you think? Find the rate at which the diameter decreases when the diameter is 10 centimeters. So what are we asked to find here?
dw over dt.
Brilliant, thank you. That's it. That's the question. So remember what we did last time? We started with the volume, so we don't forget. So this is 4 pi over 3, the radius to the third for the sphere. Easy to remember because if you differentiate this, you get the surface area, which is 4 pi r squared. No, we don't need this. I'm just reminding you how easy it is, if you remember the volume of the sphere, to find the surface area. Okay. Now, we're talking about diameter. You already told me that the diameter is 2 times the radius, 2r. I don't know anything about the radius. I have to replace the radius by w over 2. So r equals w over 2, and it has to go into the formula. So then s equals 4 pi times w over 4, w squared over 4, because I have to square. I will simplify. So I get that S, the surface area, is pi w squared. That's all I needed. The simplest possible form. Why am I starting with this? Because that's what I have. That's the information I'm given. Now I'm ready to differentiate both sides. And I put a dot just to remind us that both are functions of time. You don't have to. I just want to make sure that you remember that these are functions of time. So can anyone differentiate both sides? And tell us what we get. Anyone, please, give it a try. It's okay if you're wrong.
The left side's going to be ds dt.
Of course.
And 2 pi w times w, or yeah, dw dt.
Awesome. Now we are told this is what we are after. This is our variable. I will divide all this by this. So dw over dt. This, you cannot separate them. This is one thing together. So 2 pi w. Now I will say when w is 10 and ds over dt is -1. And it's done. So the numerator is -1. The denominator is 20 pi. Of course, I will approximate. And I will get 1 divided by, be very careful, if you omit parentheses, that will be a tragedy. Unless you put divided by 20 and divided by pi. So if you omit parentheses, you have to do it like this, 1 divided by pi, and the answer further divided by 20, and that is correct. But if you do this, if you write 1 divided by 20 multiplied by pi, that will be a tragedy. Here's why. The calculator will divide 1 by 20, and the answer will be multiplied by pi, which is a totally different story. So the answer is 0.0159, but of course with minus in front. So be very careful, do not do this. Okay, so minus, of course, it's negative. Measurement unit, this over this. W is measured in centimeters and time is measured in minutes. So what is the measurement unit for -0.0159? Anyone? Anyone, please?
Centimeters a minute.
Very good. Okay, let's come up with a list of questions that I would like you to review. And for the rest of the time, I would like us to review whatever you want. So number one, derivatives, right? You will not be asked to use f prime of x as the limit as age approaches 0 from the difference quotient. No. This was in the previous chapter. You're not going to be asked to use this in this test, on this test. Derivatives using rules. Logarithmic differentiation. 3. Of course, all the rules, the product, the quotient, the chain rule, all of them here. So please review logarithmic differentiation. Also, please review how to differentiate, which is the logarithmic differentiation. Maybe I shouldn't put it here. So f to g prime. Okay, you have to apply log, and then you have to apply implicit differentiation. So I'm going to erase this, implicit differentiation. Then we are looking at related rates. Which we just did. You are allowed to use the tables at the end of the book. So I highly recommend. I can post this file, or just so I took them out so that I can scan them. I scan them and I post them in all my classes. So take this with you just in case. You have graphs, you don't need everything because we haven't discussed everything from here, but if you want, you can have all of them. There are 10 pages. What else? Number 5.
So where are those reference
They're at
pages?
the end. They're at the end of the book. The reference pages at the end. You can print them out from the ebook if you want. Or I can send everyone this file. I have it as a PDF file. Related rates. Differentials. Linear approximation. Not both, of course. Either linearization is the same thing, or linear approximation. 7. I'm browsing through the book. I don't think there's anything else. I don't think we did anything else. There's nothing okay, the exponentials. Oh, yeah. The word problems in section 3.7. So only what we discussed in class, nothing else, no other topics. What we had was we had an example today with velocity, total distance, acceleration, a positive, negative direction, and speeding up, slowing down. I can't think of anything else. What would you like to start with? Is there a problem that you would say, if I see this on the test, I may have difficulties with it, or I may not have difficulties with it, but I want to see another one? It doesn't matter to me.
I think for me would be like figuring out with the positive and negative direction. I still get confused
Okay.
about that.
Okay, so when you determine a velocity, so is there a problem that you would like to pick?
I don't have any in mind, but anyone you pick would be fine. Just an example of like the thought process with like figuring that out and stuff.
Okay, so
The test is the whole chapter 3, right?
Correct. Only chapter 3 except 3.8. We never presented 3.8 in this class. Only on chapter 3. Okay, so let's. It's a very good starting point. So I don't want to forget to just mention approximations with the formula, right? F of x plus dx is approximately f of x plus f prime of x dx. Okay, so we want to start with something like this. Perfect. So I'm going to share my screen, and we will go to, where are you guys? I lost you. Where are you guys? Okay. Okay. So let me share my screen. So we want to go to 3.7 and work on another problem. 3.7. Where is my 3.7? Here it is. Now, if you want to work on the same problem again that we did in class, we can. We worked on number 1. I presented a solution for number 2. It was quite long. You have the solution. Would you like to work on this one again?
Yeah, number one's fine.
Okay, so let's do number 1 again. Perfect. So let me copy it. So f of t equals t to the third minus 9t squared plus 24t. And that is my page 13. Perfect. So, and we know what's asking. It's asking for velocity time, okay, when the particle is at rest, positive, negative. Okay. I'm not going to ask you to graph them. Absolutely not. I'm not going to ask you to draw the diagram. we know what the diagram means. It's fine. I don't need that. So I'm going to ask the acceleration, the velocity, of course, velocity first, and acceleration when a particle is at rest and moving in the positive direction and a negative direction as well, and speeding up and slowing down. That's all I need. Okay, and here is for 0 to 6. Fine. So for the velocity, we have to find the derivative. So this is 3t squared minus 18t plus 24. For the particle, so this is v of t. So at rest, I have to set v of t equal to 0. You can use the calculator and determine the solutions, or just simplify and factor. Because when I divide both sides, so this is 3t squared minus 18t plus 24 equals 0. Definitely, I will divide both sides by 3, and I get t squared minus 6t plus 8 equals 0. So then t minus 2 and t minus 4 equals 0. So I get t equals 2 seconds. Do not forget the measurement unit, please, and 4. So I will immediately, and this is extremely important for chapter 4, please understand this table. This is very important. So v of t, and immediately leave room for a of t in the same spot. I know that a of t's acceleration comes in much later, but please leave room here. You need it under the velocity, not later. Okay, you can create this and then copy the table again, but there is no need to do that. I just needed more paper. It's the last page here. Okay, so 0 to 6, we have 2 and 4, and that must be 0 and 0. All you have to do is just plug in numbers to the left of 2, between 2 and 4, and between 4 and 6, as we also did today.
Where did you get the 6 from again?
It's in the problem, 0 to 6.
Oh, okay. Okay.
So